Hi, I am Samantha Friedler, and the experiment that I conducted is titled The Effects of Copper Sulfate Pentahydrate on Pole Bean Seed Germination. Heavy metals are a group of metallic elements with high densities, atomic weights, and numbers. They are found throughout Earth's crust and are naturally present in soil. Examples of these elements include mercury, copper, and arsenic. Despite their natural occurrence, geologic and anthropogenic effects drastically increase the concentrations in which they are present in soil. Activities that are found to increase heavy metal concentrations include mining, burning fossil fuels, the use of fertilizers and pesticides, and the smelting of metals. In high quantities, these metals become incredibly toxic and cause a wide array of problems to their surrounding area. Prior to this study, I researched how different heavy metals affected a wide array of plants. I was made aware that heavy metals are often absorbed through plant exudates and inhibit the production of cytoplasmic enzymes. Additionally, I learned that the processes of bioremediation, phytoextraction, phytostabilization, phytovolatilization, and microbes can be used to depollute areas contaminated with heavy metals. This research specifically tracks the short term effects of the chemical copper sulfate on pole bean seed germination in order to gain an overall idea of its impact on plant health. Pole bean seeds were used due to their relatively easy nature to grow and germinate. Copper sulfate pentahydrate was used in light of this being an at home experiment and its solubility in water. Prior to doing this experiment, I hypothesized that if copper sulfate was used at lower concentrations, it would have a less damaging effect on the plant's germination. Additionally, I thought that there may even be a positive effect on the plant at a very low concentration because copper is a vital nutrient for plant growth. This is a list of the materials that were used to conduct the experiment. The lamp, bowls, saran wrap, Sharpie, and paper towel were used for the setup of the experiment, and the micropipette, copper sulfate, funnel, measuring spoons, test tubes, and pole bean seeds were used for the reaction. This is the list of the concentrations of the solutions. The amount of water was kept constant in each test tube, and the amount of copper sulfate was increased by 2.1 grams. These measurements were calculated using information from data collected in effects of copper on the growth, photosynthesis, and nutrient concentrations of fasciolus plants. To conduct this experiment, I labeled 8 test tubes with a specific quantity of copper sulfate and a number to indicate what bowl they corresponded to. I then set the test tubes aside. Next, I dampened a paper towel and laid it inside one of the bowls. I then placed 4 seeds on top of the towel and set the bowl aside. After this, I measured out the quantity of copper sulfate I needed using the measuring spoons and used a funnel to put it in the correct test tube. I then measured out the water and used the funnel to add it to the test tube. Once the solute and solvent were in, I shook the test tube until a clear solution formed. I then used the micropipette to measure out the quantity of the solution I needed and dropped it on top of each of the seeds' coats. Lastly, I threw out the tip and began the process again for the other concentrations of the solutions. After all was done, I waited 9 days for the seeds to germinate before recording the results. After germinating for 9 days, the results proved that as the concentration of copper sulfate increased, seed development was increasingly damaged, and some seeds didn't even sprout. In bowls 5 and 6, black speckles began to appear on the coat, and there was very minimal plant growth in comparison to the control group. All in all, this research greatly backs the theory that copper sulfate negatively impacts plant health and especially affects seed germination. These are images of the seeds in each boll after 9 days of germinating. As you can see, boll 1 grew much more than any of the other bolls. This is a graph showing the correlation between the concentration of copper sulfate and the number of seeds that germinated. As we go from boll 1 to boll 6, we have a decrease in the number of seeds that germinated. In boll 3, black speckles had appeared on one of the seed surfaces. This was most likely due to mold growth. In boll 6, one of the seeds turned brown, which was also probably due to mold or fungus growth. This chart shows the observations that were recorded after the germination period. Due to the usage of copper sulfate, this project needed to be disposed of safely. The chemical was disposed of in the trash. All health guidelines indicated by the New York State Department of Environmental Conservation Division of Materials Management were followed. Future research involving copper sulfate should delve into the ways in which the chemical can affect the human body. It is already known that it quickly absorbs into the bloodstream and causes rapid eye irritation and organ damage. Using this information, future research should further explain its mechanism of action in the body and its overall long-term effects on health. Thank you for listening.